Now students, in this video we will be looking at different ways to combine functions, okay? 5 ways actually, to be exact. Your heading for today is called Combinations of Functions. Combinations of Functions, lesson 1.4, and be sure and include today's date, okay? Combinations of Functions, lesson 1.4, and be sure and include today's date so that your notes are organized. Alright, let's continue on. Now, the 5 ways to combine functions that we are going to be looking at are pretty simple actually: adding, subtracting, multiplying, dividing, and composition of functions. Now, you've covered most of these in Algebra 2 in the past. We're going to go a little deeper than probably how you covered them in Algebra 2, but for the most part, it'll be very similar. Most of these combinations are pretty easy, okay? So we will go through these pretty quickly. Let's go ahead and start off with addition, okay? Copy these two functions if copy these two functions in your notes, if you would please. F of x equals 2x plus 1, and g of x equals x squared plus 2x minus 1, okay? Now the first thing I want to show you guys while you were copying these two functions down is the notation for adding functions. This is acceptable, f plus g of x, and this is acceptable, f of x plus g of x. Okay. Now, if you ever saw this notation, that just simply means to add the two functions together, and whatever expression you get out, then put 5 in for x everywhere there's an x, okay? So, let's come over here. Let's add these two functions together, f plus g. So my f function is 2x plus 1. It's always safe to put these in parentheses, just to make sure there's no confusion on your signs. Plus g, so plus, and then your g function, which is this right here. Also, putting this function in parentheses. Now, there's a positive sign in front of this parentheses, so I'm going to multiply the positive sign through to get rid of my parentheses. There's a positive sign here. I'm going to multiply the positive sign through to get rid of my parentheses. And now I can simply combine like terms and I'm finished. Isn't that easy? It's really, really simple. Students, it's like this. If you remember your basic fundamental simplification rules in algebra, you should be fine with today's work, okay? Alright. I only see one x squared term, so I'm going to put that first. Next I see a 2x and a 2x. That would be 4x. And then next I see a positive 1 and a negative 1. And of course, they're going to cancel each other out. And so there we go. Just like that, I found f plus g of x. Or you could also say, I found f of x plus g of x. And by the way, think about it for a second, students. If I asked you to find this, g plus f of x, you'll get the exact same answer, because this function plus this function is the exact same thing as this function plus this function. The order doesn't matter. Now, what if I would have said to find this right here? Well, you first add your two functions together, and we did that, and we got that right there. And then, everywhere there's an x, you put a 5. So we would have 5 for this x right here, squared, and then plus 4. Then parentheses, and then 5 for this x here. Well, that would be 25 plus 20, which would be 45. Okay? Alright, let's continue on. Now, let's take a look at subtraction. We're going to use the same two functions, okay? So here's those same two functions. Now, the notation for subtraction is f minus g of x. Or, of course, just like the last problem, f of x minus g of x. Okay, let's start with our f function first. Put it in parentheses, 2x minus 1, and then minus your g function put it in parentheses, x squared plus 2x minus 1. Now, there's a positive sign in front of this parentheses, so we're going to multiply a positive sign through, and that gives you 2x minus 1. Now take this negative sign and multiply it through, and that gives you negative x squared, negative 2x. And then negative times a negative would give you a positive 1. Basically, all of your signs inside the parentheses changed. Now combine your like terms. Negative x squared, there's only one x squared term, so I'm done with that. Here's a positive 2x and a negative 2x. They cancel out. Here's a positive 1 and a negative 1, and they would also cancel out. So when you combine these two, you're getting, or when you subtract these two functions, you're getting negative x squared. And students, I did notice one mistake I made. Right here is a positive sign, and when I copied the function over here, I put negative. So that should be plus, okay? So that gives you a positive 1 here. So positive 1 and positive 1 is a positive 2. Now, students, just like the other problem, if I would have said f minus g of negative 3, that means you would subtract the two functions and get this, and then everywhere there's an x, you put negative 3. Okay, I'm not going to do that, but you get the idea. Now, unlike the last problem, f plus g is the same thing as g plus f. However, here, remember, f minus g is not the same thing as g minus f, okay? So understand that. We are not going to do g minus f of x. These are just too easy to do. There's no need to waste any more time on these. But you understand f minus g is not the same thing as g minus f. When you're subtracting, the order does matter. Okay, moving on. Multiplication. Alright, let's take these functions here and let's multiply the two functions together. Now, here's the different notations you can use. F times g of x is one notation, or another notation would be f of x times g of x. Now, be very careful that you put a dot here and not a circle like this. Don't put a circle, okay? Because this notation here means composition. It does not mean multiplication. So make sure you're very careful if you use this notation here, okay? But we're going to multiply these two functions together. Now, before I do that, please understand that f times g is the exact same thing as g times f. In multiplication, the order does not matter, okay? So let's go ahead and multiply these two together. So my f function comes first, in parentheses, x squared plus 1. My k function comes next. Actually, I should have put a k right here, and I apologize. It should be f times k of x. F times k of x, or f of x times k of x, okay? That's my fault. Please fix your notes on that, okay? Because we have an f function and a k function, alright? So, my f function goes here, x squared plus 1, times my k function, x squared minus 1. And here we go. Take your x squared and multiply it through, and you'll get x squared, x to the fourth, minus x squared. Then take your positive 1 and multiply it through. Positive 1 times x squared is x squared. Positive 1 times negative 1 is negative 1. Okay? Obviously these cancel out, and you're left with x to the fourth minus 1. Okay? There we go. So f times k of x is x to the fourth minus 1. And once again, if you were given this notation here, f times k of 5, that simply means multiply your two functions together, and then whatever you get out, go ahead and put 5 in for x, and get out a number, okay? So there we go, okay? That's multiplying two functions together. Now, let's move on and take a look at division. Alright, almost done. Division. Okay, here's the two functions I would like you to work with. So let's go ahead and copy these two functions down, and let's divide these. f of x divided by g of x. Now you do understand, students, that order when it comes to division does matter. So f of x divided by g of x is not the same thing as g of x divided by f of x, okay? Do understand that? Okay? Alright, moving on. Now, let's go ahead and divide some functions. So f square root of x over g square root of 4 minus x squared. Okay? Now, students, look, let's really work this through. Let's talk this through together, okay? First of all, if you remember, when you have a square root over a square root, it is the exact same thing as this. You can put one big square root around the entire fraction. Now some students do that, and then they want to reduce their x's here. They want to take one x away from here and put a 1, and take one x away from here and put an x. And that is totally incorrect. Okay, you cannot do that because there's two terms in the denominator. Now if this denominator was one term, like this, 4x squared, then you could reduce the x's. Take one x away from here, leaves you with the 1. Take one x away from here, leaves you with 4x. You can do that if there's one term up top or one term on the bottom, but we don't have that. We have two terms here. Also, another mistake students like to make is they like to take the square root of the x squared or the square root of the 4. Now students, you cannot do that. This is two terms. Now if it was one term, x over 4x squared like this, then you could leave square root of x up top, and the square root of 4 is 2. The square root of x squared is x, and that would be acceptable. That's totally correct. But you can only do that if you have one term right here. You cannot take the square root of the 4 or the x squared because there's two terms here. So to be honest with you students, there's really no need to write your answer like this. Now, if you did, I have no problem with this answer. But the more acceptable answer would be this right here. There's really nothing you can do. So you're finished. So f divided by g of x equals this right here. Okay? This expression right here. Students, there is one thing I'd like to show you that you really need to be careful about, okay? Problems like this can be really challenging if I ask you to find the domain. So, understand that, students. Let me just get rid of a bunch of stuff here. Give us some space to work with. What if I asked you to find the division of f and g, and then I said, find the domain of your given function, of your function or that you get when you divide two functions? Well, students, listen, you've got to be able to do this, okay? Let's start with the numerator. Do you see any red flags in the numerator? I do. A radical. You can never take the square root of a negative number. So we know x has to be greater than or equal to 0. Okay? That's for the numerator. So I'm going to put a fraction line right here. Now let's talk about the denominator. Now we've done these before, guys. We want, if it was just 4 minus x, no problem. You would say 4 minus x has to be greater than or equal to 0. Bring the 4 over, make it negative. Divide by negative 1, so you turn the arrow. And there you go. You've got your domain, okay? But this is not linear, it's quadratic. You have an x squared right here. So I've taught you what to do. You take the inside and you set it equal to 0. Negative x squared equals negative 4. Divide by negative 1, x squared equals 4. Take the square root of both sides. X equals plus minus 2. Okay? Now, that means when you put in 2 or negative 2, you get out 0. Listen, students, that's usually okay. Can you take the square root of 0? Yes, yes, yes. But in this case, listen to me, this radical is where? It's in the denominator. Can you ever have a denominator that's 0? No. So, if you put in positive 2 or negative 2 for x, you will get out the square root of 0, and the square root of 0 is 0. So that does not work for the denominator. So understand, when we draw our number line here and put negative 2 and positive 2, usually you would close these 2 points like this. okay? Do not close them. They have to be open because you do not want to have 0 in the radical because the square root of 0 is 0. And that gives you 0 in the denominator, okay? Alright, now I've taught you what to do. You check a number here. You check a number here, and you check a number here. Now, we've done some of these in the past, so I'm not going to do another one for you. But trust me, this region doesn't work. This region doesn't work. This one checks out. So my domain for the denominator is going to be x's greater than, not equal to, greater than -2, and less than 2. So let's see if we can find where these two expressions intersect, okay? And then we'll have our domain for the entire function. The numerator says you gotta be greater than what? 0. So even though down here it says it has to be greater than -2, be very careful. Let's get a picture of the graph at the top. Let's get a picture of the top here. Here's 0. X is greater than or equal to 0. Okay? Here's the denominator. We got -2, +2, open point, everything in here. Now, obviously, up here you have to be greater than 0, so you cannot be over here at -2. So I'm going to put a point at 0 here. Close that point and come up, okay? So this no longer works over here. Students, it can't, because the numerator says your x has to be greater than 0. So we have to go where both of these domains agree. They both have to agree. Okay, so I know x has to be greater than 0, so I know this part over here won't work. Now, down, up at my top here, it says greater than 0, which means you can go as far as you want to the right. But hold it, that's not true, because the denominator says you have to stop at 2. So where both of these domains agree is from 0 to 2. 0 is inclusive, 2 is non-inclusive parentheses. So there's the domain of this function. That's a really, really tough one. I hope that makes sense, okay? If not, you might want to go back later and watch this again, okay? Alright, moving on. Okay, no, I don't think any of these are necessarily difficult. However, if I had to choose the most difficult out of the 5, this would be the one. So in other words, I have saved the most difficult one for last, okay? We're going to look at something now called compositions, okay? So please watch carefully how we do composition of functions. Let's do a couple of these, okay? Write down these two functions if you would, please. Copy these down. While you are copying these down, let me give you the notation. Composition would be f of g of x. Or you could say f of g of x. Okay? Or another way would also be composition of f of g of x. Any of those are fine, okay? Alright, I'm gonna stay with the one to the left over here. So f of g of x. So this notation here means find the composition of these two functions here. Now here's what you do. You start on the outside, which is f, and you write your f function. Here it is. Why did I write my f function? Because f was the outer function here. Now, after you write f, then you're going to put a parentheses for everywhere you see an x. However, make the parentheses big enough so that you can put this whole function into the parentheses. So here's x, I put a big parentheses, and then plus 2. Now, what is your inner function? G. So you pick up g and you put it into the parentheses. And now you simplify. There's a positive sign right here. Multiply your positive sign through. And that eliminates your parentheses. And then, when you simplify, you have negative x squared plus 6. Okay? Alright, so let's erase this here. And let's put that right up here. F of g of x equals negative x squared plus 6. Okay, now let's do another composition. Let's go the other direction. Let's do g of f of x, okay? So, what is my outer function? G. So let's write our outer function. There it is. Now, everywhere you see an x, put a parentheses big enough for f to fit into. So 4 minus, here's an x, so put a parentheses, then bring down your squared. Now what is your next function? Your inner function, f. So pick up f and put it right here. Okay, now, normally you would want to take the negative sign and multiply it through, but remember, you have to do exponents first, okay? So we have 4 minus x plus 2 times x plus 2, okay? Now, I'm not going to take a lot of time and do this for you, but if you took x all the way through and take your 2 and multiplied it through, you would end up with this right here. X squared plus 4x plus 4, okay? Now don't forget there's a negative sign out here. Now we multiply the negative sign through. All of those signs will change. 4 minus x squared minus 4x minus 4, okay? Your positive 4 and your negative 4 will cancel, and you're left with this right here. G of f of x equals negative x squared minus 4x. Okay, so that's a little bit of, hopefully, a review. I mean, I know you've done some of these in algebra, but that's how you do composition of functions. Now, I want to show you a little bit of relationship here that I think is really, really cool. Please take some really good notes. Please, students, okay, take really good notes and watch this. Now, see this composition right here? Watch, this is really cool. Watch this, okay? If you take your inner function, which is what? G, and put an ordered pair in for G, anything you want. Let's put something easy in like 1, okay? So we put a 1 in for x. Now watch this. 4 minus 1 squared. Well, 1 times 1 is 1. 4 minus 1 is 3. Now move to your outer function. In this case, in your composition, your outer function was f. So, whatever you got out right here, put it in over here. Okay? So now put a 3 in for x. 3 plus 2 is 5. Got it. Now, look at your composition function. Watch this. I put a 1 in, I got out of 3. So because I got out of 3, I put a 3 in, I got out of 5. Now, see this number here and this number here. Guess what? They satisfy your composition. Try it and see. Put a 1 in. 1 times 1 is 1. Then you got negative 1 because the negative sign. Negative 1 plus 6 is 5. When you put a 1 in, you got out of 5. That will always work if you put an input into your inner function and get an output, and then take your output and put it into your outer function and get an output. Then the input of your inner function goes with the output of your outer function, as long as these two inner numbers match. Now, everything I said there did not even make sense to me, okay? So I'm not asking you to repeat all that. I'm just trying to show you that sometimes, well, no sometimes to it. I'm just trying to show you that you don't necessarily have to have this function right here. You do not necessarily have to have that function to find an ordered pair for the composition. Okay, as long as you know what the inner function is and the outer function is, you can put a number in, get out a number, take that same number, put it in, get out a number, and this number here and this number here will satisfy the composition function, okay? Why don't you guys try this on your own real quick, okay? Let's use g of f of x, okay? So let's put inner for your inner function, then outer for your outer function, and then composition for your composition function, okay? Now, let's pick a number, and let's put it in for your x here. Let's pick a different number. Let's use a negative number. Let's use negative 3. Okay, now, go ahead on your own, and I want you to find what this value right here would be, okay? Right here. Go ahead and figure that out. I'm going to pause a second. Go ahead and do that. Watch your signs. By the way, what is your inner function? It's the f function. What's your outer function? G function, okay? So be careful. Okay, this really shouldn't take too long. Put a negative 3 in for x. Negative 3 plus 2 is a negative 1, okay? So, when you put in negative 3, you got out negative 1. So now we'll take this number and we'll put it in right here, okay? into your outer function g. Okay, go ahead and do that this time. Okay, you should get out 3. Let me show you why. 4 minus, then put parentheses for your x, -1, then put your squared. Do you multiply these first? No, you do not. You square first, exponents first. So 4 minus a +1, because a negative times negative is positive, and 4 minus 1 is 3. Okay, so do these two inside numbers match right here? Yes, they do. So you know -3, 3 should satisfy your composition. Let's see if it does. Okay, here's your composition. Let's put -3 in for x. Okay, you square -3, you get 9, but there's a negative sign here, so -9. Okay, -4 times -3 is +12. Combine those and you'll get a 3, which is what you're supposed to get, 3. Okay, so that's something to think about. That will help you solve some problems later on when we're dealing with composition. Okay, alright, let's continue on to something else. Now, let's look at how to find the domain of a composition. It might not be exactly what you think it would be, so please take some really good notes, okay? Alright, let's go ahead and find the composition of f of x. Excuse me, f of g of x, okay? Now I'm going to do this quickly. You can take some notes. Let's find the composition of these two functions. So my outer function's f, so I write my f function. Okay, then where the x is, I put a parentheses big enough for my inner function, which is g. So here's my inner function, pick up g and put it right here. Now, whenever you square a square root, you get what's on the inside. So 9 minus x squared minus 9. Of course, 9 minus 9, they cancel out. So you're left with -x squared. Now, students, I need you to really focus and think about something, okay? Students, if I simply gave you this function right here, and I said, find the domain of -x squared, you would say what? All real numbers, right? I mean, think about it. X could be anything. There's no fractions or square roots or anything. However, please listen to me carefully. Mathematicians have decided that whenever you are asked to find the domain of a composition, you do it a little differently. So if I ever ask you to find the composition like you just did here, okay, and then find the domain of the composition, it's done a little differently, okay? So here's how you would do it. Please pay really close attention. First of all, remember, we found f of g of x. Okay, got it? That's what this equals right here. Now, watch carefully how you find the domain of a composition of functions. You don't just look at the composition and say, oh, it must be all real numbers. There's something else that you do, so please listen carefully. The first thing you do is you find the domain of each of the functions, okay? So let's start off with f. The domain of f here would be what? It's very obvious. All real numbers, because you can put anything in for x, anything you want. Over here, however, is a little different. Now, I'm not going to take time and do all this work. Notice we have a quadratic under a radical. I'm not going to do the number line and check the regions. We've done enough of those. But I'm going to tell you right now, the domain for this function right here would be this right here. X is greater than or equal to -3 and less than or equal to 3. Okay, got it? So, with that in mind, now here's what you do. You have to find the function. Now, this is very, a little confusing, so pay attention. Let's review real quick. First of all, you find this composition right here is where these two domains intersect, or in other words, where they agree. So over here, the domain is anything, everything, whatever. Over here, it's -3 to 3. So where do these two agree? Right here. And I'm going to show you why right now. Does this fit into all real numbers? Definitely. Does this fit into this? Definitely. So this is the domain. Now remember, here's what your composition looked like. It looked like this. -x². So normally you would think the domain of this function is all real numbers. But whenever you're doing a composition and you're asked to find the domain of the composition, you take the two given domains and you find where they both agree, or in other words, the intersection point of where they both agree. Okay, so there it is. This would be the domain of this function right here. Okay, alright, hope that makes sense. Study that and make sure you know how to do those. Alright, moving on. Lastly, let's try a couple of problems in which we take the composition of two functions and find the original functions. In other words, we're going to go backwards. That sounds like fun, huh? Actually, it can be a little difficult. I'm going to give you this right here, and you're going to go backwards and try to find these two functions here. So it should be interesting, okay? Now, we do this, by the way, in calculus. Quite often in calculus, you have to go back and find the two original functions that gave you the composition function, and they call that decomposing a composition function. And so let's go ahead and give this a shot and see how we do. Okay, here we go. Let's try this here. Okay, copy this in your notes. I'm telling you, actually, I don't really like how they wrote this. They put h of x, and to be honest with you, I'm going to change that right now. I'm going to change to something like, well, I'm trying to think. We'll leave it like this for now because the book has it like this. But what they want us to do is they want us to break this up into two functions. So now, come on, students, think about this. You're looking for groups that you could have made a substitution into. For example, do you see how I have a whole group here to the third power? Do you see that? Now think about this for a second, students. What if I had a function that was x cubed? Got it? And what if I had a function that was 3x minus 5? Okay? If I were to pick this up and put it into this function over here, it would look like this. If I picked this up and put it into x over here, it would look like this. So maybe, and by the way, there's more than one answer to these, but I'm decomposing this composition into two functions. So here's what I'm thinking. And again, I don't really like this notation right here. I'm going to go ahead and change it now and call it h of g of x. I'm just making that up, okay? So when I took h of g of x, I got this. Well, g is my inner function, so I would say g of x would be this right here. H is my outer function. I'm going to say h is over here. H of x. H of x. Now, does this make sense, guys? Let's check it and see. H of x equals this. G of x equals this. Got it? So if I told you guys to find h of g of x, you would start with your outer function h, and where the x is, you would put a big parentheses, and then put g into it. And look, guys, that's what I got right here. So here's my two original functions that I had that gave me this composition right here. Okay? Now there could be more than one answer. Please understand that, okay? There could be more than one answer. You could say that, let's see, that one function is 3x minus 5 to the third power, and the other function is just x. And so we could say this is g of x. You don't have to take notes, just watch this. H of x. There we go. So start with your outer function, put h, then put x in for x, and you would get the same thing, okay? So there's more than one answer, but this is definitely one answer here. Right here, where if I took these two functions right here and took h of g of x, I would get this right here. Let that sink in, okay? It's not easy to do, but it's something you should be able to do, okay? Let's try another one. Copy this in your notes, please. Let's try this one here. Now again, students, you're looking for like a group, something in a radical or something raised to a certain power, something like that. And I'm seeing this group x minus 2 raised to the second power. Now I'm going to go ahead and change this to something else. I'm going to change this to f of g of x. In your notes, go ahead and do that, okay? So I've got an f function, a g function. Now I'm thinking this. Hold it. What if I had an x in the denominator right here? Just a big x like that. So for one function, I'm going to write 1 over x. Now, what if I put the 1 over x squared? There we go, 1 over x squared. Now, what if I said my other function is x minus 2? Remember, I'm going to pick up x minus 2 and put it in for x. And I'll get this right here. So, this would have to be my f function, f of x. This would have to be my g function, g of x. And I think I've done it. I think that's it. Let's check and see, okay? Let's take f of g of x of these two functions and see if we get this. F of g of x. Take your f function, your outer function, and we got 1 over x squared. I'm going to put a really big parentheses for x. My inner function is g, so pick up g and put it right here. And look at that. Booyah. Alright? Perfect. Just like that, okay? So we took a composition and we decomposed it into the two original functions, okay? Alright, I hope this video has been a help to you guys. If you have any questions, don't hesitate to call or email.